Right, guys, yesterday we looked at the degree of the polynomial, and last week, and we talked about the degree meant that's the maximum possible number of zeros. Okay. Today we're going to talk about how to find all of those zeros sometimes when they're not real. All right. The rational zero theorem sounds all complicated. I'm pretty sure you did this in Algebra 2 honors. I don't know about regular. But the rational zero theorem says that if you have a polynomial with rational coefficients, real coefficients, it even says integer coefficients, any rational zeros have to come from the factors of the constant over the factors of the leading coefficient. All right? So it's written like this up here on your notes sheet. It's plus or minus all the factors of the constant divided by the factors of the leading coefficient. All right, I'm going to skip this example and come back to it. I don't know that you have these. I just want you to help me real fast because this is exactly what it will say on the quiz. It'll just say list all possible rational zeros for this function. All right, what is the leading coefficient and constant on this example up here? Can you all see that one? The constant is, okay, is negative 36. The leading coefficient is 2. All right, we need all the factors of that. What are all the factors of 36? There's a lot. 1, 2, 3, 4, 6, 9. Let's see, 6 times 6, 9 times 4, 3 times 12, 2 times 18, and 1 times 36. Okay. In the denominator, we have all the factors of 2, which were just 1 or 2. All right. Now, on a test or quiz, you will have to write out what this means. You can't just leave it like this. You don't have to write out the positive ones separate from the negative ones. So if you write out plus or minus, all of those over 1 would just be whole numbers, yes? And this is a long list. I would probably not put this on a quiz because I don't want to grade it. Okay. Now we're going to put them all over 2 because that's the other denominator, right? So 1 over 2 would mean 1/2 could be a rational zero. 2 over 2 would be 1, which is already on our list. 3 over 2, 4 over 2 is already on our list. 6 over 2, 9 over 2. 12 divided by 2 is 6. 18 divided by 2 is 9. And 36 divided by 2 is 18, all of which are already on the list. So this would be what you would need to list. Now, that's actually 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. But it's actually 24 possible zeros. Does everybody understand? Because they all could be positive or negative. All right. Help me with this problem. This is more like what I might put on a test or quiz. What are the factors? You got to memorize where they come from, guys. Factors of what over what? Okay, factors of the constant, which is negative 21, over the factors of the leading coefficient, which is 3. It doesn't matter if it's positive, negative, just all the factors. So the factors of 21 are what? 1, 3, 7, and 21. And the factors of the denominator are 1 and 3. So if you are to list all of them, you write 1, 3, 7, 21, positive or negative. So we're up to 8. But what else? You got to put them all over 3. 1/3. 3 over 3 is already on our list. 7/3. Any more? 21 divided by 3 is 7, which is already on our list. So there are all the possible rational zeros. Yes? No, you can leave it like this. Yeah, you just, great. Nathan asked, do we have to list them all further than that? This, you can't leave it like this, but you can leave it like this, okay? You don't have to write plus or minus 1, plus or minus 3, plus or minus 7. Everybody okay? All right, going back to this question that I believe you have on your notes. It says x cubed minus 5x squared minus 17x minus 6. Okay? it says list all the possible rational zeros. Well, it's just all the factors of 6 over all the factors of 1. So the list is just plus or minus 1, 2, 3, or 6. Everybody okay? Then it says determine which, if any, are zeros. We could look at a graph. We could check them all by plugging them in. We could find f of 1 and see if it comes out 0 or not. We could find f of negative 2. We could do synthetic division. We could do long division for fun. Okay? The fastest, easiest way would be just to graph it, which is what they did. I'm not going to take time to type it in my calculator. They graphed it and found that negative 2 was a 0. Just reviewing from yesterday, if there is a 0 at negative 2, okay, so over here at negative 2 it was crossing somehow. It was actually going this way, right, because it's a positive degree 3. Then they put down the leading coefficients, 1, negative 5, negative 17, and negative 6. This is already on your paper, so just watch. Drop down, multiply. Add would be negative 7, multiply would be 14. Add would be negative 3, multiply would be positive 6. If you do this on a test or quiz, and you have graphed it, and it's shown that it's a 0, and you do this, and it does not come out 0 at the end, something's wrong. Okay, if it comes out with a remainder. So then you need to recheck that it's a 0 on your calculator. If you can't find your mistake, I don't care if you're in the middle of a test, bring it up to me and say, I know this should be a 0, it should be coming out 0, I can't find my mistake. I know when this synthetic division gets long and complicated, it's really easy. My favorite is usually to go like something times 0 becomes, 6 times 0 is 6 or something stupid. So just, if you can't figure out where you made your mistake, bring it up. I'll look for it, see if I can help you find your mistake. I'm not going to fix it for you, but I'll tell you, look here, okay? Because I know. I don't want you to get a whole problem wrong because of something silly like that. This depressed polynomial means x squared minus 7x minus 3. All right. To solve that, we have to use the quadratic formula. I was going to show you, and maybe we will later in a few minutes, I was going to show you, Josh showed me a feature of the calculator that if you have a newer calculator, there's an app that solves the quadratic formula. You don't have to have a program. But we tried it with this problem earlier today, spent 5 minutes on it, and it comes out ugly decimals, and that's not the form of the answer that you're going to be allowed to give. So we're going to do it together, okay? Quadratic formula, help me out. Negative b plus or minus minus 4ac over, okay, so give me numbers from here. Opposite of b would be positive 7 plus or minus the square root of negative 7 squared would be 49 minus 4 times 1 times negative 3 all over 2 times 1. This one is really easy because you get something that doesn't simplify. What do you get in the radical? Yeah, so it's 7 plus or minus the square root of 61 over 2. And what was the other 0 we already found? Negative 2. All right, does everybody understand that that's 3 zeros total, or do you need me to write out once with the plus and once with the minus? Everybody good? So we found all 3 zeros. Only 2 were rational, 2 were irrational or crazy decimals. Did you try it, Josh? Did you try this one?
Yeah, I was trying to see if there's a way that it would show.
Yeah, I put it in a plus bi form and it still didn't. I mean, it's not imaginary anyway.
Okay.
But I have a program that will give you that as a radical, but I couldn't get the solver to do it. All right. Moving on. The next question says list all this. You have this one, guys. List all possible rational zeros of this. Then determine which, if any, are zeros. You're going to do that by graphing. In order to get through the lesson today, I have graphed these and taken some screenshots to help us get through it a little quicker. But I don't want you to forget that that's what I did, okay, was I graphed it. I didn't pull numbers out of thin air. I just graphed it. All right. So what are the possible, it says list them, all the possible zeros of this. Factors of what over what? Constant over the leading coefficient. So that all comes down to what? That's it. Okay? Then I graphed it, and this is what it looked like. Now, if I was smart, and I still have it on my calculator, I think. Okay, when I get this, I really should test if there's zeros. Because I will tell you there's a problem on here that I did 3 times because I kept typing it in wrong, because there's some really long, messy ones on here. But I typed this in, I got this picture. What does it look like the zeros are at? -2, okay? So I'm going to type trace -2, enter. Is it a 0? Okay, if it doesn't come out 0, then it's not, right? All right, we have +2, enter, and what do you think the other one is? 5, enter. Okay, can there be any more? No, we found all 3 and they were all real. So the real zeros, they were all real. I don't even need to write that. I just write the zeros. We're at, where did we find them? Good job. That's all it asked you to do. We have confirmed them. How else could we do it? We could do synthetic division, followed, do -2, and then after we did that one, do +2, and after we did that one, we should come out with an x minus 5 at the end so that we had all 3 factors. Courtney.
So then the leading, not the leading coefficient, the constant over the leading coefficient, the numbers you got from that are the rational zeros?
Those are possible.
Oh,
All of our zeros can only come from that list.
oh,
Okay?
I get it.
Yep. That's just a list of possible ones. Let me go back and talk about that for 1 second. If this were my list, Courtney, down here, and I look and I try 3 and it doesn't work, I could try 7/3 because that's 2 point something. It's just less than 3. So if it looks like it's at 3 and it's not, I should probably try that 7 divided by 3 and see if that was a 0. Do you see? It's a list of possible things to try. All right. I wanted to say one more thing about this question. Later it's going to say write the factored form. What is the factored form of this? X plus 2, x minus 2, and x minus 5. It is always x minus the 0. Does everybody understand that? X minus a -2 became plus. X minus 2, x minus 5. All right, and these are also linear factors because there are no x squareds left. All right, the question, though, just asked us to find the zeros, and we did by graphing. All right, the fundamental theorem of algebra said that a polynomial of degree n has at least 1 0, either real or imaginary, in the complex number system. So if we graph a cubic, it's always going to cross the x-axis once, yes? Because it's going to go up or down forever. But if we graph a quadratic, does the parabola always cross the x-axis? No, but it would have imaginary zeros if it didn't have real zeros, if it doesn't cross the x. All right, the corollary we're talking about today says that the degree tells us the zeros, whether they're real or not, and they can be repeated. Just as a quick example, if I had this, that has 4 zeros, but they're all 4, or are all 0, I mean. It's 0 is the 0 of multiplicity 4. Okay, so that's considered 4 zeros. Eric? All right, if we had a y equals, I don't know, I'm just going to keep going here. We're going to run into some examples in a second. All right. The conjugate root theorem sounds all complicated. It just says that if you have a plus bi as a 0, then a minus bi also has to be a 0. Or if 2 plus 3i is a root, then 2 minus 3i has to be a root. They come in conjugate pairs, as long as the polynomial you had started with real coefficients. The same is true for radical. 2 plus square root of 6, 2 minus square root of 6. Has to be a 0. All right, this is what it looks like on your paper. It says the conjugate root theorem says if a plus bi is a 0, then a minus bi is also a 0. Everybody okay? So write a polynomial function of least degree with real coefficients in standard form that has 0 and square root of 2 times I as zeros. So right now it lists 0, and I'm going to write that as I square roots of 2. If I square roots of 2 is a 0, what else do you know? The conjugate of that has to be a 0. That one's really a weird one, but what would the conjugate of 0 plus I square roots of 2 be? Be negative I square roots of 2, okay? I don't really like this example, except that it's easier than the ones we're going to do after this, okay? If it had said 2 is a 0 and negative 3i is a 0, you would have said positive 3i also had to be a 0. All right, do you understand that these have to come in conjugates where the sign changes? We're going to do one in a minute where it's like 4, negative 1 plus I, and negative 1 minus I would have to be the conjugate pairs. Everybody all right? This one is just kind of weird because it has a radical in it, but it actually makes it very easy for the next part of the problem. All right, so it has to have at least how many zeros? Right? There's 3. Everybody okay? When it says least degree, we could make it have some more zeros because it says we know at least there's one at 0 and one at square root of 2. We could make one at 5, one at 7, one at negative 8. But do we really want to FOIL that bad boy out at the end of this problem? So we're going to go with least degree as these 3. Okay, how do I write those as factors? X minus 0, which we usually just write as x, yes. X minus I square roots of 2, and x minus negative I square roots of 2, which would be plus. Okay, are we done? Is that real coefficients in standard form? No. This is an x. I'll leave him out there for a minute. If I FOIL conjugates together, do you remember this? Something should simplify, yes. So let's try it. I'm going to distribute the x. X times x is x squared. X times positive I, this mess back here, be positive x times I square roots of 2. I'll just leave it like that. This times this in the middle would be negative x I square roots of 2. All right, be careful. What is this last term times this last term? Negative I times I is I squared. Square root of 2 times square root of 2 is 2. All right, what's I squared? Negative 1. This says minus I squared times 2. So it's minus negative 1 times 2, which would be minus negative 1 times 2 would be plus 2, yes? Okay, so we have an x out front. These two canceled out, and we had an x squared plus 2 back here. Okay, it's not looking too good here. It's kind of all spread out. I don't know if I move that over. Whoa! Okay. It says real, it's standard form. I would tell you you could stop here. You'll notice later I put a note about that. But for now, let's finish the problem. If we distributed this out, we'd get x cubed plus 2x Is that what your notes have? Okay. Underneath here, it says that's the answer. Everybody okay? Painful, but you're all right? All right, we're going to do one more in a long, complicated, painful manner, and then I'm going to teach you the shortcut. It says find all complex zeros of this polynomial given that 2 plus I is a 0. All right, if 2 plus I is a 0, what else is a 0? 2 minus I. Okay. How many zeros does this have total? Anybody? It's degree 4, so it has 4 total zeros.
Does it have to?
If it has it doesn't have to have 4 unique zeros.
Oh.
Okay?
Oh, no.
It doesn't have to have 4 unique zeros, so they can be repeated. All right. Now, we have to write these as factors. So we have x minus 2 plus I and x minus 2 minus I. It's always x minus. Now, if I distribute the negative through here, what will I get? Anybody? Minus 2 minus I. All right, over here, if I distribute this negative, I get at minus 2 plus I. All right, I need everybody paying attention because we need to FOIL these two together. It's one massive FOIL problem, right? I'm going to distribute this x to all 3 of these terms back here. X times x is x squared. X times negative 2 is negative 2x. X times I is plus ix. Good so far? Now we're going to distribute the negative 2 to all these terms back here. Negative 2 times x is another negative 2x. I'm going to actually write it under the like term to try to line them up and save myself a little bit. Negative 2 times negative 2 is positive 4. Does that have a like term yet? So I'm going to put plus 4 back here. Negative 2 times I is negative 2i. There is not a plain old negative 2i anywhere. I'm going to put that back here. Then I need to distribute this negative I to the x, the negative 2, and the I. Negative I times x is negative ix. Do I have one of those already? I have a positive one here, so underneath I'm going to write negative ix. Negative I times negative 2 is what? Positive 2i. I'm going to write that under this one back here. Negative I times positive I is negative I squared. Okay? You can write that anywhere. It's actually going to become what? Positive 1. Because it's minus an I squared. I squared is negative 1, becomes plus 1. So it's actually going to match up with this guy in a second. I can replace it and write it as a plus 1. All right. I wrote stuff so that we can bring down the x squared. We can add these together and get a negative 4x. These drop out. 1 plus 4 is 5. Negative 2i, positive 2i drops out. When you multiply these together with conjugates, you will always get real coefficients. Now, there are 2 more zeros to this. All right? The fastest, easiest way would be to graph and see if you can see them on the graph. It says we could use long division, and I know you're going to think I'm torturing you, but I want to do it by long division. You don't need to write it down because I want to review what we did yesterday. Could someone read me that polynomial from that problem?
The first one?
The big long one, x to the 4th.
Minus 5x plus 2x squared plus 19x minus 30.
And the one we just found, anybody? X squared
Minus 4x plus
Okay. Help me quickly. X squared into x to the fourth. I need a what? Then I distribute that to all three of these terms, so I get an x to the fourth minus 4x cubed plus 5x squared. Then remember you do what? Subtract, or change all these signs and add. So I get negative 1x cubed minus 2x squared if I bring down the 19x. All right, help me out. What do I need to multiply by now? To get a negative 1x to the third, I have to multiply my x squared by negative 1x. Distributing that to all three of these terms again gives me negative 1x cubed plus 4x squared minus 5x. The step everybody forgets. Change the signs and add. We end up with a negative 6x squared plus 24x minus 30 if we bring this guy down. Okay, it goes in evenly. How many times? Negative 6x squared to here. If I multiply by a negative 6, I get negative 6x squared plus 24x minus 30. Do you notice that it came out even, right? So this is the other factor. X squared minus x minus 6. Is that what I wrote down, guys? So what are the other two zeros? How can I find the other two zeros if I didn't want a graph or didn't have a graphing calculator? This factors how? Minus 3 plus 2. So where are the other two zeros? Did anybody graph it? Nobody graphed this mess? I don't know if I have that one in my calculator. X. I don't think I have that one typed in here.
I have negative 2 and positive.
Yep, negative 2 and positive 3 is what we got. All right, would have been much faster to just graph them, right? All right, practice 2. It says write a polynomial function of least degree. Josh?
On that last one, did we know that it had 4 zeros just because it gave us an imaginary one?
No, it could have had a total of 4 imaginary ones.
So
We knew it had 4 because it was a degree 4 polynomial. If we had graphed it,
does like any degree have that many zeros, but just the ones that we don't see are imaginary always?
yes, or they're repeated zeros. Yes, yes. That's fascinating to me because it means when we see a graph that does this, there's a repeated 0 here, but there's also 2 zeros that made this happen and they're imaginary. Okay? Yes? I'm sorry, did I not finish? Oh, you're right. Okay, thank you. The linear factors, guys, if these are the 4 zeros, here are 2 of the linear factors, x minus 3 and x plus 2. The other 2 are from this, and that didn't factor nicely. It gave us these horrible 2 factors up here that we started this problem with, right here. X minus 2 minus I and x minus 2 plus I. You have to get it all the way down to x's for it to be linear factors. So the 4 zeros, we did x minus this, x minus 2 minus I, x minus 3, and x minus negative 2. All right, more practice. I'm going to teach you the shortcut. This says write a polynomial function of least degree with real coefficients in standard form that has the following zeros. There's a negative 4, then there's a comma, then there's a 1, then there's a comma, and then there's a 4 plus I. Can it be degree 3? No. If it has 4 plus I, it has to also have 4 minus I. So it has to be at least what? degree 4. All right. It says here, my little stars say, as long as there are integer coefficients, you don't have to go all the way to standard form. So, factors. What does this mean as a factor? X plus 4, or x minus negative 4, which is x plus 4. This as a factor is x minus 1. This as a factor is x minus 4 plus I. And this as a factor is x minus 4 minus I. This is a quiz question. On Friday, there's a question just like this. This would get you partial credit right here. To get full credit, it says you have to have integer coefficients. So you have to do something with these until there's no i's. All right, you distribute the negative. And you get to this. Now, you can do what we just did. I'm going to go through it really fast one more time. I'm going to distribute all that out. You'd have an x squared, a minus 4x, a plus ix. Then when you distributed the negative 4, you'd have a negative 4x plus a 16 and a minus 4i. And then when you distributed the negative I, you'd have a minus ix, a plus 4i, and a minus I squared. I didn't line them up very well. I just was trying to get them down. Which is an x squared, a minus 8x, this and this cancel, this and this cancel. 16 minus I squared would be 17. All right, you can do it that way. There is a shortcut. Please find a place on your notes to write this down. The shortcut is x squared minus the sum of the roots times x plus the product of the roots. Really fast example. If I had roots of negative 1 and 5, the factors would be x plus 1 times x minus 5. When I FOILed it out, I'd get x squared minus 4x minus 5. These two numbers add up to the opposite of that. Those two numbers multiply to make this. Okay? There's no reason to do that. We know how to FOIL. But when the numbers were 4 plus I and 4 minus I, what is the sum of those? 4 plus I plus 4 minus I is? We spent a whole day on this. Remember complex numbers? 4 plus I plus 4 minus I is 8. Okay? I need to do the product, so then I do have to FOIL this together. 16 plus 4i minus 4i minus I squared becomes what? 17. 16 minus I squared would be 17? Okay, so that was the product. So we would write x squared minus the sum times x plus the product. Is that what we got a minute ago when we did this the long way? Did you write it down somewhere? All right, go back to finish this question. The question said, write it out in standard form. I got this far. Do I have real coefficients everywhere? So I'm going to go with, you can be done. Does it look like a good time to keep FOILing that out until you have standard form? Okay. I don't want to spend the rest of my life FOILing things together either. So I'm going to go with stop here. You can't stop here for full credit because of the i's in the problem. All right, we're going to try this problem. It says, write each function as the product of linear and irreducible quadratic factors, which is what we just did, ones with real coefficients. And then as the product of linear factors, and then list all the zeros. All right, you will start all of these problems by graphing to find some real zeros. I graphed this one to save us time. Okay, this is what it looked like. I also tested and found -6 and 4 were the zeros. So how do I list the factors? Well, let's just start with what I know. I know -4 is a 0, and what else? What'd I say, 6? Okay. In any order, we're going to do synthetic division. In any order. So I'm going to do -4 and then 6. You could do 6 and then -4. 1, 2, -15, 18, and -2, 16. Okay, somebody with a calculator help me quickly. Oh, it is +4 and -6, totally. I didn't, yeah, it's whatever the 0 is. I thought I had -4 and +6. Didn't look again. +4 and -6, the actual 0 goes in here. Thank you. All right, bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. All right, you have to do it successively, which means you don't go back to the original polynomial. We're trying to get this down to something we can factor. So now we do the other 0. Bring down, multiply, add, multiply, add, multiply, add. What does that tell us? What did that 4 tell us a factor was? If there was a 0 at +4, one factor is x minus 4. If there was a 0 at -6, one factor is x plus 6. What is the remaining polynomial right here mean?
No.
X squared plus 9. Okay. Does that factor? It does not factor. Are we at part A, the product of linear and irreducible quadratic factors? Yes, so this is the answer to A. The answer to B is we have to factor this somehow. So my answer is find C first. The zeros are at 4, -6, and what? If you have x squared plus 9 equals 0, x squared equals -9. When you square root, what do you get? X equals plus or minus, what is the square root of -9? 3i. So the zeros are at 4, -6, 3i, and -3i. I don't have room, so I'm just going to leave them written like that. So the linear factors would be x minus 4, x minus 6, and then x minus what? Yep. X minus 3i and x plus 3i. Is it? Thank you, this is plus 6. Yep, thank you, thank you, thank you. All right, so these are the linear factors. All right, we have 5 minutes left. Is there one more example on your paper?
Yeah.
With a whole bunch of room, right? Okay. If you had to list all of these, you'd have all the factors of 615 over all the factors of 4. That sounds like a nightmare, right?
Yeah.
Okay. So I graphed it. And I looked, and it only looked like it crossed twice. One of them was at -3. I thought the other one was at -1, but what does that show right there? Can you see that? When I typed -1, enter, it said it's actually at 100. My window was really tall. Okay? -1 didn't work. I cheated and used the 0 calculator. You know, the function second graph, find the 0. And it's -1.25. Is that a rational zero? Rational means can be written as a fraction. Negative 1.25 is negative 1 1/4 or negative 5/4, right? Okay. So that is a rational zero that we can use. Let's start with synthetic division. What are we going to do first, maybe? The negative 3. Okay, I'm going to need somebody type in a calculator because I don't think I can do these very fast. Whoa. Move that down. Oh, nope. Just kidding. Seriously? All right, we're just going to leave it there. We're going to bring this down and write 4. 4 times negative 3 is negative 12. Negative 27 times negative 3 is 81. 124 times negative 3. Thank you. Times negative 3 is negative 615. What do you know? Now what? Yeah, we can use negative 1.25 or negative 5/4, either one. Okay, they're equivalent. You want me to use the decimal? Most of you are happy with your calculator in a decimal. Bring down the 4. 4 times negative 1.25 should be negative 5. Added to negative 27 is negative 32. Times negative 1.25, 40. Is it right? 164 times negative 1.25. Negative 205. A miracle. All right. So far I have as linear factors x plus 3 and x plus 1.25. What's left over is what? 4x squared minus 32x plus 164. What do you notice there? Can we take out a 4? I'm going to rearrange this order over here. Shh, guys. Okay, I get x squared minus 8x plus 21. Is that right? All right. 41. Thank you. Thank you. All right. I can distribute the 4 through here just to get rid of the fraction. This would be 4x plus 5. X plus 3. To get linear factors, I'm going to have to use quadratic formula or something here. Okay? I'm going to show you if I have time. It's under apps. It's one that says, I have a lot of apps on this calculator. It's called Poly Simulator. I thought I could go faster from this way. Where is it?
It's not by default. I don't know what that is.
Okay. Then you press enter and it's number 1, the root finder. This is a degree 2 equation. I really want it in I's if it's possible. Then I go to next. I put in 1, negative 8, and 41. And it says 4 plus 5i and 4 minus 5i. So the linear factors are x minus 4 plus 5i and x minus 4 minus 5i, and I'm fine with you leaving it like that. Okay, thank you.